Hello viewers, welcome to this episode with PyMath. In today's episode, we'll go through a question on indicia equation. It's a question that people have shared their perspective on. We will look at this question and also throw our weight behind it. But before we go on to the question, I want to ask that you follow PyMath on this space. PyMath is also on other social media space, which you can follow. You can ask your friends to follow PyMath here. And you can make this video available to them by sharing it across your space. Let's go on now to the question and share our perspective on it. Now, the question here says, solve for n if, in brackets, 2n to the power of n squared minus 1 equals 1. To solve this problem, we'll quickly recall one of the laws of indices that says that any number raised to power 0 is 1. So if you raise 100 to power 0, you get 1. You raise 1,000 to power 0, you get 1. You raise 1,000,000 to power 0, you get 1. Here you will just represent the numbers by a. A to power 0 gives you 1. Now, with that in mind, we would apply what we just said so we can rephrase this indicia equation into that form so we can be able to solve it. So we'll have, in bracket, we have 2n to the power of n. So let's raise it to that power, to the power of n squared to the power of n squared, okay, minus 1, okay, equals 1. All right. Instead of having 1 here, we'll change this now to look like the law we just stated above. So this becomes, it becomes 2n to the power of 0. All right. So let's put that in the form we want it to be. It becomes 2n to the power of 0. So looking at this, we can now, let's pull this a bit up so we'll have the space to work our solution. So looking at this, we can, of course, work out what we have here by the principle I'll state shortly. All right. This principle states that if you are dealing with indicia equations and it happens that the bases are equal, in this case, 2n on the left-hand side equals 2n on the right-hand side. If the bases are equal, then the indices are equal. In this case, n squared minus 1 is equal to 0. So this is what the principle says. But to put that down, let's pull this a bit up so we have the space that we need to write our equation. So this becomes n squared, since we said equal bases gives equal indexes or indices. So n squared minus 1 equals 0. So that's what you see there. So this is equal to 0. You can see the bases are 2n on the left-hand side, 2n on the right-hand side. The indices, n squared minus 1 equals 0 here. So equal bases, you have equal indices. All right. Now, from here, our n squared, let's put that up there. Okay, n squared will be equal to 1. All right, so this is what you have next. You still need to pull this up a bit. Okay, let's pull it up a bit. All right, so we'll have the space that we need to solve our problem. Okay, all right, so here we have, okay, we have n squared equals 1. Now to find the value of n of course will be equal to, because if you want to take find the value of n, it means you take square root of both sides. So but this time it will be plus and minus square root of 1. Plus or minus square root of 1. Okay, let's take up 2 more options so we can get the square root of 1. Okay, square root of 1. Okay, so that's what we have there. So plus and minus square root of 1. I want to take off this other part of it that is not necessary. I need to take this off. All right, good. So we have this as we want it to be. Okay, so that becomes plus or minus square root of 1. So if you take the square root of 1, it returns 1. So our n, of course, will be equal to minus 1, comma, or, so we'll have minus 1 as one of the solution. Then, of course, n is also plus 1. Okay, so we have two solutions here for n, minus 1 and plus 1. It appears again that we can also generate another solution for this same question. Let's see that solution. How do we generate that solution again? Well, let's pull all of this up again, all right, so that we can have the space to generate the other solution that exists in this question. All right, so pull these ones up, okay, and pull this up. Okay, we just got these ones. All right, now if you look at the question again, where we have the question itself says, we need to bring out that question. Here's the question. I think I need to drag it down. Here's the question again. All right, let's drag it down to this point so we can see what we are working on and work on it very well. Another way we can approach the solution for this question is to divide both sides of the equation by the inverse of the index to the left-hand side. The index to the left-hand side is n squared minus 1. So if we divide both sides of the equation by the inverse, what we'll simply have is 2n. If you divide this index by its inverse, it gives you 1. All right? So this becomes equal to, if you divide this by itself, not by its inverse, if you divide this by itself, to multiply both sides of the equation by the inverse of the index. So if you multiply this index by its inverse, you will get 1. All right, so that's the idea. So this equals 1, that equals 1 to the power of n squared minus 1. So that will be n squared minus 1. N squared minus 1. All right. So this will be, actually, it's going to be 1 over, it will give us 1 over, all right, 1 all over, because we multiply by the index, okay? Let's put it in a way that we want it to be. So we raise it to that power, okay? That's to the power of 1 over, okay, in a way that we actually want it to be. So that will be 1 all over, okay, it's not giving us that way. All right, so let's take this off, okay. All right, we actually want to raise it to, let's put it in a different way so that we can have what we want to have. It's not what we want, it's not what we want, okay. All right, so it equals 1 to the power of, let's put it in the way that we want it to be, to the power of 1 all over n plus 1, okay, or rather n squared. So that's a power actually, n squared minus 1. Okay, all right, so that's raised to that power. So that's raised to that power. Now, when you have, if you have 1 to the power of any number, it returns 1. Okay, so eventually this becomes 2n equals 1, right? So let's put this up and see that. So what we have here becomes 2n equals 1. So finally, if 2n equals 1, then it follows So if 2n equals 1, then it follows that n equals 1 all over 2. Okay, so we have a third solution to this problem. All right, so we have gotten our solutions to the question. Let's look at put them side by side and see all of the solutions. The first set of solution we got was plus and minus 1. Okay, so let's pull this up so that we can see our solution. Okay, here's the solution we got at first. Then the second set of solution we got here is n equals half. So if you slot in minus 1, plus 1 and half into this equation, you will get that the left-hand side will be equal to the right-hand side. So the solution has come out. So we have 3 sets of solutions for this indicial equation. Okay, but that's what we just saw here. Now you can make this video available to your friends by sharing it in your space. You can also ask your friends to follow PyMath here so they can gain more of math skills on how to solve some of their math problems. I look forward to seeing you in another episode. Remain